Hello students, I am Madhukar Supri, Department of Chemistry, Vijayanagara College Hospital, B.Sc. University, Ballari. So we take the B.Sc.lll Sem class, and under this we are studying now Thermodynamics-Part-l. So under this Thermodynamics we have to study now limitations of the first law and the need for second law. First we have to know what is this first law. This you would have studied in PUC classes, in nothing but delta U into Q minus W, change in internal energy is equal to quantity of heat absorbed minus the work done. So we have studied now limitations of the first law. According to the first law of thermodynamics, there is a relationship between heat absorbed and the work performed by a system in a given process, but it does not tell about the direction of flow of heat. This is very important. It does not tell anything about the direction of flow of heat, which direction to which direction it is moving. According to first law, for example, it is not impossible to extract heat from ice by cooling it to a low temperature and then use it for warming water. That means it is possible to extract heat from ice by cooling it to a low temperature and then use it for the warming this water. But from experience, it is known that such a transfer of heat from lower to higher temperature is not possible without expenditure of energy. That is, without doing some external work. Without doing some external work, it is very difficult to do this process. On the other hand, it is known that heat flows spontaneously from higher to low temperature. This is a common concept. Heat always flows from higher to the lower temperature. This is first limitation. Second is, according to first law, the energy of an isolated system remains constant. First law is telling about this during a specified change of state, but it does not tell whether a specified change or a process including a chemical reaction can occur spontaneously. That is, whether it is feasible. This is the second limitation. Thirdly, first law states that energy of one form can be converted into an equivalent amount of energy of another form. But it does not tell that heat energy cannot be completely converted into an equivalent amount of energy. There is a loss of some amount of work in this process. This is not explained in that first law. Thus, there is a need for another law, usually the second law of thermodynamics. To explain these limitations, we have to study now the second law of thermodynamics. Now we have to study the need for second law. This second law helps us to determine the direction in which energy can be transferred. B. Helps us to predict whether a given process or chemical reaction can occur spontaneously. Next, C. Helps us to calculate maximum fraction of heat that can be converted into work in a given process. To explain this thing, first we have to study the spontaneous process. What is spontaneous process? They will ask this question in the examination for usually 2 marks. What is spontaneous process and give an example. So, a process which takes place of its own without an external aid is called a spontaneous process. And this spontaneous process is irreversible and is a natural process. The examples are, out of 4 you have to write any one in the examination. The first one, you know that water flows from higher level to the lower level. We cannot reverse the direction of flow without some external aid. But by the electric pump, we can lift this water from lower level to the higher level. Second, heat flows from the hot end to the cold end spontaneously, but never from cold to hot end. But by means of refrigerator, you know this process. By using refrigerator pump, heat can flow from cold region to hot region. Third one, always the gas expands spontaneously from a region of high pressure to a region of low pressure or in vacuum. Next, fourth one, electricity flows spontaneously from point at a higher potential to a point at a lower potential. Out of these 4, you can write any one in the examination as an example. Second law of thermodynamics. Different statements of second law of thermodynamics are there. Among these 4, any one you can write in the examination for 2 marks. The first statement, type of statement, all spontaneous processes like the flow of heat from hot end to cold end, gas expands from high pressure to low pressure, or the flow of water from higher level to lower level, etc. are thermodynamically irreversible. Second, the complete conversion of heat into work is impossible without transferring a part of heat to a cooler body. Third one, you can write, it is impossible to construct a machine working in cycles which will transfer heat from lower to higher temperature without the aid of external agency. Or you can write the fourth one, the entropy of the system is constantly increasing, or you can write in the another form, entropy increases in irreversible processes. Among these four, anyone which is easier for you, you can write in the examination, it is for 2 marks. That is second law of thermodynamics, different statements. Then we have to study another important topic is Carnot cycle and its efficiency. In this class we will study definition of Carnot cycle only. The next coming class we can study the calculation of efficiency of this Carnot cycle. Definition: ideal reversible thermodynamic cycle. This Carnot cycle is an ideal reversible thermodynamic cycle in which working substance undergoes 4 operations of, what are the 4 operations? Isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression, and back to its initial state is called Carnot cycle. In the next class we will study this explanation about this Carnot cycle and its efficiency. I hope you understood this. Thank you all.